The following data represent the percentage of U.S. families with children whose income is below the poverty level. Use a graphing calculator to draw a scatter plot of the data. Fit quadratic, cubic, and quartic functions to the data. Use the values of r squared to decide which function is the best fit. Draw the function of best fit on the scatter plot. And then C, use the function of best fit to predict the percentage of U.S. families with children that were below the poverty level in the year 2017. So here we're wanting to do polynomial regression. So we're going to use this data and enter it into our calculators and then determine if it looks like it is a quadratic, a cubic, or a quartic function. And we're going to find the one that best fits the data. So I'm going to start by entering this data into the calculator. So I've preset that and entered the data into my calculator. So this is the same as we've done before. Go to Stat and Edit, enter the X values into one list and the Y values into the other list. So with the data entered into my calculator, I'm ready to make the scatter plot. So I'm going to go to Second and Stat Plot, and I'm going to turn on a plot. So I turned on plot 1. I'm doing a scatter plot, so that's the first icon. My X's are in list 1, my Y's are in list 2, and I'm going to choose the square as my mark, and the color, I'm going to leave it blue. So now all I need to do is choose an appropriate window to be able to graph this. So I'm going to go to Window. Now our smallest X value, which in this case is actually T, they're using the variable T. The smallest value is 1, the largest value is 12. So I need to either use 1 as the X-min or a convenient number slightly below that, such as 0. And for X-max, I'm going to use either 12 or something slightly above that. So let's use maybe like, let's go a little bit more than 1 year. Let's use like 15. With a scale of 1 will be fine. Now, my Y values, the smallest Y value, which in this case is technically the letter P, but it's our Y variable. The lowest value that we have is 14.5. So we either want to use 14.5 or a convenient number just below that. So maybe like 14. The largest value that we have is 18.5. And so we either want to use that or something convenient above that, like 19. So we're going from 14 to 19. A scale of 1 would be appropriate. So if I graph that, this is what that data looks like. Okay, so it certainly doesn't look linear. Okay, it's questionable. I wouldn't exactly say it looks quadratic, cubic, or quartic, any one of them. But we're going to let our calculators find these models and see which one is the best. So I'm going to second quit and go back to the home screen. Now to do quadratic, cubic, or quartic, we go to Stat and Calc. And so on my calculator here, number 5 is quadratic regression, number 6 is cubic regression, number 7 is quartic regression. So I'm going to start with quadratic regression. My X values are in list 1, my Y values are in list 2, so I'm just need to say calculate. And so I get, this would be the parabola that best fits this data. Now notice R squared is 0.8375, which is fairly close to 1, but it's not super close to 1. The model that has the closest value to 1 is going to be the best. So keep that in mind, 0.8375. Now let's go back and let's do a cubic regression. So stat calc, cubic regression. Again, my X's are in list 1, my Y's are in list 2. I'm going to calculate. So now we have our cubic function. R in this case is 0.949. Pretty good. That's pretty close to 1. So maybe the cubic's the best, but let's check and see what the quartic is. So I'm going to go to Stat and Calc and do the quartic regression. Again, X's are in list 1, Y's are in list 2. Calculate. Oh, so our quartic, we have 0.982. If I round to 3 places, that is the closest one to 1. So our quartic model is the best model. We created our scatter plot. I'm going to write down our quartic model. So the quartic model is best. And again, that's because r squared equaled 0.982 approximately. So if I round each coefficient to 4 places, our model is going to be P of t, P because that's our y variable, and t because that's our x variable. So P of t equals 0.0031 times t to the 4th power minus 0.0980 t cubed plus 0.9055 t squared minus 2.2467 t plus the constant 16.0040. So this is our best model right here. And again, it's the best because the r square value was closest to 1. Now we want to draw this to see how well it fits. So if I go to y equals, now I could paste this in, but I'm going to just type it in. And I'm going to use the letter x instead of t on my calculator. And I'm going to use y2 because it's set to be red, and I want to see the contrast. So 0.0031 x to the 4th minus 0.0980 x cubed plus 0.9055 x squared minus 2.2467x plus 16.0040. And if I graph that, we can see that that model does in fact fit the data pretty well. So we've done part A and part B, so we just need to finish up with part C. Use the function to predict the percentage of U.S. families with children that were below poverty level in the year 2017. So if 2016 is year 12, then 2017 is going to be year 13. So 2017 means t equals 13. I'm just going to plug 13 in my function. So P of 13 is going to equal 0.0031 times 13 to the 4th power minus 0.0980 times 13 cubed plus 0.9055 times 13 squared minus 2.2467 times 13 plus 16.0040. And I'm going to punch that in my calculator to see what we get. So 0.0031 times 13 to the 4th power minus 0.0980 times 13 cubed plus 0.9055 times 13 squared minus 2.2467 times 13, and finally plus 16.0040, and so that is 13.0595. So if I round that to one place, which is where everything else has been rounded to in the data, that would be about 13.1. So about 13.1% of families with children were below the poverty level in the year 2017.